Hi guys, in this video we are going to discuss the problem B matrix of differences from educational round 141 that was rated for Div 2. The problem states that for us a square matrix of integers of size n into n, let's define its beauty as follow. So for each pair of side adjacent elements x and y, so the adjacent elements are those that actually that at least share a side. So for example over here, 1 shares a side with 4 as well as with 3, but it doesn't shares a side with 2, although it shares a diagonal but not a side. Okay, so we have to write out the number that is x minus y. So in this case we can write 1 minus 3 absolute value, 1 minus 4 absolute value of this. These would be the two neighbors of 1, and then find the number of different numbers among them. So this is the question. They've explained a bit more about it, like how many numbers we can have and all. So in totality, since we are having a n into n size matrix, we should have all the unique numbers from 1 to n square. Then they have given the test cases. So the test cases are pretty lenient. Test cases only range from number of test cases are up till 49, and n can go up to 50. So a lot of brute force ways can be used for it, but we'll be trying the optimal way out. So let's understand the problem first, like what the problem actually demands. So what we can say is that we have to construct a array or a 2D array. So we'll only be given with n, so that's the only input we'll be having. For this n, we'll have to construct a n into n matrix, all of whose elements would be in the range 1 and n square, with no duplicate elements, right? So every element would appear only once in this entire matrix. Then for every adjacent element, that would be, let's say, element x and let's say element y, we'll take the absolute value of it, we'll note this down, and the number of these values. So for example, let's say x minus 5, we wrote down all the values, so we got 2, 2, 3, 4, anything, like we can get any values, right? So for example over here, number of unique values is there's a 2, we have a 3 and 4 and a 5, right? So number of unique values is 1, 2, 3 and 4. So 4 unique values we have. So we have to basically maximize this number, and we have to return them a corresponding matrix which has this maximum number. So what can we do over here? A trivial thing to think of is that what if we write down the number in ascending order. So for example, let's say n is equal to 3. For that I'll be having 9 numbers in total, 8, 9. Now the biggest difference over here can be 8, right? So that is a difference I can consider. Now what if the element to the next to 9, or the element that is connected to 9, so let's say 9 has several connected elements, it could have element to its left, to its right, to its top and bottom. So one of the element is already 1, as we said. Now we can combine it with 2 also. So if 2 is also connected to it, so this would give us a value of 8, this would give us a value of 7. So yeah, these two are also different, so that we can do. Now what if 2 is connected to it? So that would give me a value of 6. That also is a unique value, so we are increasing our answer, we are maximizing the answer. What if 8 is connected to 3? So this would give me a value of 5. Great, we are again maximizing the answer. So that's what we want to do. Let's say 4 is connected to 7, then we'll be having a value of 3, so on and so forth. So this is the spiral pattern we want to follow. However, so we can say that the array, let's write this thing in a like a 1D form. So in a 1D form I can say that the array I want is 1, 9, 2, 8. So first this, then this, then this, then this element. After that I'll take 3, then 7, then 4, then 6, this 5. So this is the array I want. But they haven't asked the answer in 1D but in 2D. So what I can say is, so let's say the first row itself contains the first 3 elements, but then I had to connect 8 to 2. Now how can I do that? So if I place 8 over here, then it would be a problem because 2 is now not connected to 8. So what is a better solution for here? So what you can say, 8 is connected over here, let's say, right? Then we can say 3 is connected over here, then 7 is connected over here, then 4, then 6, then 5. So this becomes a spiral matrix, something of this form. I hope you got that. It's a bit complicated to implement. Not that complicated, but a bit complicated. We have a better solution for this. What else can we do? So another thing we can do is that, let's say 8 is over here, so it should be connected to 2, and the only option for connecting it to 2 is placing it 8 at here, so there's no other option for us. So let's place 8 over here. Now I have to connect 3 to 8, right? So I can connect 3 over here, then 7 over here, then I can say 7 needs to be connected to 4, so let's place it 4 over here, then 6 over here, then 5 over here. So basically the structure is something of this sort. So like I'll be going in the right direction first, then I'll be going to the left direction, then to the right direction. So this would be valid for any I, and this should give our answer. So what we technically need to code it up as, so let me show you the code for this. So what I'm doing in the code is that firstly I'm making that 1D array, so I'm storing the 1D array as vec. You can name it anything you want. So this 1D array is the array that would actually contain be containing the values 1928 so on. Once I'm done with that, in a single loop I'm firstly printing the left to right things, right? So let's say this is the, initially it would be the row 0, right? So in row 0 I'll be printing in ascending order, or the order where we are traveling from left to right. Then I'll print a new line, and after that I can increment my I, because now I'm talking about row 1. Now I'll have explicitly have to check that if I is less than n, only then I can proceed. So if that is the case, then what I can proceed is the reverse order. So basically I'm like writing the reverse order over here. Over here what I was doing is I into n plus j. So this is an easy way of opening a, you can say it, a matrix in a 2D form, right? So I'm actually running two loops. So I into n plus j would give me the correct index, and then over here what I'm doing is that print the elements in the reverse form. So I'm going from the from the right to the left, and that's what I'm printing over here. Then I'm giving it a new line. Yeah, that's it for the code. Let's try to copy it and run it. So this is the problem, and let's try to run this code. Yep, cool. So this works. So this was technically easy problem, just a observation you had to get that they make a spiral matrix or make it in some sort, so that the all the values are actually connected. Yeah, that's it for the video. Let me know if you found this useful, and if you want me to make video on any other topic, I'll be more than happy to do that. Thanks a lot, guys.